So hello everyone, welcome to part 2 of chapter 17. We went over diversity of animals. So we were following this tree, this phylogenetic tree. We said the trees came from a protista. There were protista-like protozoans. They were behaving like animals, but they were single-celled and eventually turns into multicellular. So all animals are multicellular. So that's one feature all of them share. Then the branch divides. And then it says that there's no tissues or true tissues. Everything has true tissues except the sponges. Sponges have no tissue, no true tissue. It's just a bunch of cells working together. And then we start dividing it based on symmetry. Bilateral symmetry is when you cut something head to toe and it gives you a mirror image. And radial is when you cut it like a pizza and it gives you a mirror image. Doesn't matter how you cut it, as long as you go through the center, you're gonna get the equal right and left. And the only ones that had radial symmetry were cnidarians. And then if it has radial symmetry, it's going to have two germ layers, endoderm and ectoderm. If it's bilateral symmetry, it's going to have three germ layers, endoderm, ectoderm, and mesoderm. And then we further divided them into deuterostomes and protostomes. So protostome is when the mouth arises first. So the first opening in the embryo becomes the mouth, second opening becomes the anus. And under protostomes, we had exodazoa, means the ones that molt, so that are arthropods and roundworms, annelids, mollusks, and flatworms. I asked you guys to remember their protostomes, and I told you guys don't have to know what this means. So you can skip this part, but you have to know the molting, and they all are protostomes. So today, this is where we are. So we are going to talk about deuterostomes. So for deuterostome, mouth arises from the second opening. The first opening becomes the anus. So under deuterostomes, we have two groups. We have echinoderms and we have chordates. We humans fall under chordates. So phylum Echinodermata includes sand dollars, sea stars, and sea urchins. So let me show you some pictures of those. Oh, I know what happened. So this is the slide I was trying to get to. Okay, so here you can see some pictures: sand dollar, sea cucumber, sea urchin, and sea star. Now the word ecchi means spiny. They have spiny skin. You can see some spines here, but you can see the spines really on the sea urchin here. And the derm means skin, so they have spiny skin. Ecchi means spiny, derm means skin. Echinoderms are the ones that have spiny skin. Now I want you to take a look at this, and I want you to tell me, what do you guys think if it has a radial symmetry? Do you guys agree that it has a radial symmetry? So take a look at it.
Yes.
George said yes. Chris said bilateral. So let's take a look at that. I'm gonna try to draw it. First, I'm gonna draw radial symmetry. So radial. I'm gonna draw a circle. And then it has a center. So this is the center. Now, as long as you pass through the center, when you cut, it's going to give you a mirror image. So this looks same as this side, and you can cut it like this. Sorry, I meant to go through the center. It's gonna give you equal right and left. You can cut it like this. and it's going to give you equal right and left. So that's radial symmetry. Now, for the Echinodermata, we have sand dollars, we have sea star. So I'm going to try to draw a sea star here. So if I have a sea star, it's going to have 5 parts. So try my best, but anyways, and then it has a center. Now, if you cut it through center like this, and you count what's on each side, you have 2 full arms on this side and 1/2. Same thing here, you have 2 full and 1/2. Now, what if you cut it like this? Now you have 3 full arms on one side and then 2 full arms on the other side. So it's not really radial symmetry, because one way, if you cut it this way, it might give you equal right and left. But if you make another cut, you're still going through the center, but it's not giving you equal right and left. Your textbook says this has a radial symmetry, but I don't agree with that. So what I want you to write that doesn't have radial symmetry, you can say it has maybe biradial symmetry, or you could say pentamic. So penta means 5, pentamic symmetry. And penta means 5, so I'm just gonna say 5 here. Or these two fall under bilateral, you could just say it has bilateral. But I don't want you to memorize, as your textbook says, that it has radial symmetry. It does not have radial symmetry, because the second type of cut, this type of cut, does not give you the same right and left. It doesn't give you the same equal right and left. Does that make sense? Yes?
Yes.
Okay, so let's look at what some examples in this phylum. So here we have sea urchin. Sea urchin, if you go to a tourist shop, you can buy these shells. And these shells, if you count, let me find one. That's the top view. So here. And if you count, it's going to have 5 parts. 1, 2, 3, 4, 5. So it has 5 parts. It has that pentamic symmetry, or that's something unique about this group. It's going to have 5 body parts. If you take this shell and you flop it and stretch it out, it's going to give you something like sea cucumber. This is a sea urchin stretched out. The sea cucumber eats dirt, and then it poops out dirt, and the dirt that it poops out is usually clean. So whatever is in the dirt, it just absorbs that. And then sometimes there's this tiny fish that lives in the butt of the sea cucumber. Here. So it looks like a worm, but it's a fish. Lives in the butt of the sea cucumber. And if it gets pissed off, maybe you poke it or something, it's going to eject all the intestinal stuff outside. That's what it looks like. So it just gets mad and just ejects everything that's on inside. That's a sea cucumber. In terms of food, I don't know if you guys heard about uni sushi. It's a Japanese cuisine. So in terms of food, if you harvest or catch them at the right time of the year, females are going to be filled with eggs that are used for the sushi. So it's a Japanese cuisine. Have you guys had this? For all of them, Giselle, for the whole phylum, Echinodermata. Kawa said yes. Have you, so you guys had this? No? Okay, and in terms of, so this is Japanese cuisine. In terms of Westerns, you can just put sea urchin on bread. So you can, this is pretty common food. You can just put some sea urchins on bread and eat it like that. Also, sometimes these sea urchins, their population gets out of control. And then you can see the barrens, there's lots of them. And if this happens, it's going to eat all the seaweed and kelp, and that's going to mess up the whole ecosystem and all the marine organisms that maybe live on kelp and seaweed. So it's gonna basically mess up the whole system. So if you like seafood, maybe try eating uni sushi or other seafood that might use sea urchins, and maybe that will encourage the divers. Maybe that'll create an economy for it, and then encourage the divers to go out there and harvest these and catch these for the seafood restaurants, so the population can stay under control. So it can get pretty out of control. So let's go ahead and fill out this, continue filling out this table that we were filling out last time. This is Echinodermata. Echinoderms. Bilateral symmetry. Complete. And then special things, some unique things. They have spiny skin. So echi means spiny, dermata skin, derm, spiny skin. And then maybe I could say body has 5 parts. Some examples: sea stars, sea urchins, sea cucumbers. Any questions on this phylum? No? You also notice it has this 2 feet for the sea star. There's this 2 feet, and the stomach is in the middle. So they have this water vascular system. That's what you can say, spiny skin and water vascular system. So before we move on, I found some interesting videos. We will watch these if we have time at the end today, but there's one that I want to show you guys. That's eel suffers a toxic shock from a brine pool. Do you guys know what brine pool is? The brine pool is when there is high salinity of waters. It's a pool in a ocean or a lake, you can say. It's like a crater lake inside a lake. And in that area, it's a high salinity. It's 8 to 10 times more salty. So that creates a brine pool.
Cutthroat eels, scavengers, come to the shores of the brine lake in search of something edible. Some even venture into the brine. Spending too long in it can send an eel into toxic shock. Its only hope is to rise above it. It manages to escape. Others are not so lucky. The brine embalms their bodies and the casualties of decades accumulate around the margins.
It's really interesting stuff. Those of you who don't know, seawater freezes at much lower temperature than fresh water. So fresh water freezes at 0 degrees Celsius, and then seawater freezes at -4. And if you add salt to cold water, it's going to be even much colder. So it's gonna feel even more cold. So it's really interesting stuff. I found some more interesting videos. And if we have some time at the end today, I will show you these. I really want you guys to watch this one here. It's a Cambrian explosion. So there is a question for you guys. Animals commonly called worms. Actually, you might have already answered this, are classified into 3 phyla: flatworms, roundworms, and annelids. What feature distinguishes them?